Hello, Facebook students. This is Problem Solve coming on kind of late, but you can always replay to view this. I had some students that are up working on their homework assignments, and they asked me to go over completing equivalent fractions. This is for fourth graders or fifth grade students that have worksheets from their courses online, and they are having trouble completing the equivalent fractions. So I'm going to go over them. I'm going to do a few of them this evening, and when they are able to replay it, they can go through it and hopefully they will understand. So if there are some students that are online, live on Facebook, that are older than, the age that they need to be up this late. But since we are quarantined, if you want your students, or if you are a student and need to review this, just to take a break from whatever you're doing, this would be a good review for equivalent fractions. All right, so let's get started. We're going to complete the equivalent fractions. All right, so I'm going to take my time and hopefully I won't make a mistake tonight. So if this is helpful to you, to help your students at home, or if you're going to school and you are having to revisit equivalent fractions, please, please like and share, okay, if it can benefit others. Alrighty, so let's get started. Okay, so the question is, how do we complete equivalent fractions? All right, hi Facebook students. I know it's late, but you can replay this later on tomorrow. I will be live on tomorrow, hopefully a little earlier, between 3 and 4, to review y equals mx plus b, talking about slope intercepts, rise over run, the slope, the y-intercept, the equation of a line. All right, so let's get started. Okay, how do we complete equivalent fractions? The first thing you want to do is rewrite this term or this fraction. This is called your numerator. I'm going to have to move this over. Numerator, hope I'm spelling this correctly, divided by your denominator. Sounds like Terminator. Okay. So your top number is your numerator and your bottom number is your denominator. All right, so let's rewrite this. This is 3 divided by 7. And what we want to do is we want to find what is the missing number that would make this an equivalent fraction. Now I want to show you something here. I hope I spelled it correctly. Equivalent. Did I spell that correctly? Yes. So you can see the word equal and equivalent. That means that's the root word. You can say equal represents the symbol equal. So what you want to do is find this fraction that is equal to this fraction. So in order to do that, you must find the multiplication. You want to find the multiplication factor that you would use, and I'm going to use multiplication. Well, let me erase this. You want to find what you can multiply in the denominator and in the numerator, but it has to be the same factor. So whatever is here must be the same number here. Factor is your number using your multiplication factors from your timetables, okay? So let me put my equal here. And we want 70 here. And we don't know what this number is going to be, but I'm going to create a number 1 here because it cancels and go to a 1. All right, so we want to find the same multiplication that you use here, you must use in the numerator. So what times 7 will give me equal to 70? So 7 times 10 equals 70. Okay, so 7 times 10 equals 70. So whatever number we use in the denominator, we must use it in the numerator. So we have to put 10 here. All right, so 3 times 10 is 30. So 3 times 10 is 30, okay? So now we can rewrite our fraction. 3 divided by 7 is equal to 30 divided by 70. So 3/7 is equal to 30 70ths. That's a tongue twister, okay? So 3/7 is equivalent to 30 70ths, okay? All right, so I'm going to do another one so you can see, kind of get the pattern of how you complete equivalent fractions. All right, so let's just check to make sure I have everything correct. We have 3 divided by 7, that is our fraction, equal to some number divided by 70. All right, so we have our numerator and our denominator. So we rewrite 3/7 and we have to multiply by a common number or factor to match or to get 70 here. So whatever we get for this number to get 70, we know to use that number in your numerator to get that answer. So we have 7 times 10 is 70, and now 3 times 10 is 30. All right? So if they give you a problem like this and you're missing either the numerator, which we are missing the numerator. Okay, let's put that here. And I'm going to do one that you're missing the denominator, okay? So now we know how to complete equivalent fractions here. All right, so I'm going to erase and I'm going to do another one with the denominator missing. All right? Please like and share so someone can see this tomorrow if they need to review this for or do this for an assignment for their homework in the 4th grade, 3rd or 4th grade, maybe 5th grade. All right? Hopefully if you have students at home during this time, parents, this is a review for you and you'll be able to coach your child through this. All right. So let's do another one. This time we're going to do one where the numerator is missing where the denominator is missing. All right, so let's do, if we have 1 divided by 6 equal, let's see, 4. And we don't know what this number is. All right, the question is, this is missing. What is it? What is that number? Remember, this is our numerator divided by our denominator. Like Terminator or Eliminator, you know, some Marvel movie, okay? All right, so as I stated before, we need to rewrite. Let's rewrite 1 divided by 6. Trying to use different colors that hopefully is showing on the board. So we rewrote this. We're going to rewrite it. Rewrite the fraction. Rewrite it. Okay? And then the second step is I'm going to use a dot. I'm going to use a dot to represent multiplication. You can use an X, small x, or you can use a dot. It's the same thing. It's the same kind of symbol. All right? All right, so whatever we do in our numerator this time we have the answer for here, but we're going to have to figure out what it is for our denominator. All right, so what times, okay, so we know this answer. So what times 4 would give me 4? That would be 4. And remember, whatever we do in the numerator, we must do it in the denominator. All right? So now we have 6 times 4 is our answer. Our equivalent, I'll say, is 24. Okay? Now remember, the reason why I say whatever you use the rule or the reason that you have to, whatever you use here, you must use in the bottom number. You know, whatever you do in the top, you must do it at the bottom. And 4 divided by 4 is 1. That's why I put a huge number 1, because 4 divided by 4 is 1. So that number that you use here to make this equivalent, it has to divide out to equal 1. All right, so if I slash this out, 1/6 times 1, if I rewrite that, 1/6 times 1 is still going to be 1/6. And that is equivalent to 4/24. All right? So this is the first thing. You want to rewrite it. That's number 1. Number 2 is to find your factor, that whatever they provide for you to make it easier for you, that's the number you're going to want to use to find the missing numerator or denominator. All right? So that's the second step. The third step is to go ahead and multiply. And then the fourth step, I was just showing you an in-between here, that if you multiply whatever this is by 1, you're still going to get the same answer. Okay? So I just brought this down. So this is your fourth step. So 1/6 is equal to 4/24. All right? So let's do one where I do not have the numerator or the denominator to get an equivalent fraction. Okay? All right, moving right along here. So let's erase this one. Hope that you all can see the board clearly. Hello, Leslie. Hello, Gail. I know you all are probably math gurus, so this may be something you already know, but I appreciate your waving at me. All right. I hope this will be good for some of the students that will see this on tomorrow, or their parents can help them review this. All right. Let's do 4 divided by 12 equal, we don't know. So we don't know what the equivalent fraction is to this. Okay? So, if you know your multiplication tables, or the factors, we can find an equivalent fraction to 4/12. So let's try, let's rewrite it. 4/12. All right, we're going to use my dot here. And remember, whatever we do in the numerator, we must do it in the denominator. And it must divide out and equal to 1. Okay? Kind of changing my colors here. All right. So, what multiplication factor that we want to use? Can we use? We can always. We can use if we use 2 here, we must use a 2 here. All right. So 4 times 2 is 8. 12 times 2 is 24. So 4/12 is equivalent to 8/24. All right, let's try another multiplication factor. Okay, let's use our dots for multiplication. And we know we have our 1. All right, whatever we do here, we must do there. All right. So we can use 2 because if you multiply this by 2 and this by 2, you're going to get an equivalent fraction. What if we multiply this by, let's see, 4? Remember, whatever we do in the numerator, we must do it in the denominator. All right? So 4 times 4 is what? 16. Students, you must know your multiplication factors. And I think when I started last week, I was telling students or the parents, if you must, go back to these multiplication flashcards to help your students know those timetables. They must know them, okay? Especially 7s. This is my stack that I use for my children almost probably 20 years ago, and I still have them, and sometimes we still go through them even though they're in college, all right? 2 of them are in college. So don't want to preach to you about this, but you need to know your multiplication tables. So have fun, make it a game, and, do old maid and matching or whatever you have to do. Play music with it, rap with it. But your students, students need to know their multiplication tables, because without it, you can't reduce fractions, or we say simplified in the textbook, but we can't get equivalent fractions if we don't know our timetables, all right? So they sell these at the dollar store, or, you can go online and purchase them. Okay, I went on a little rabbit trail there because timetables are some of the weaknesses that I see with some students, okay? All right, so let's do one more, and let's see if we can, we didn't finish out this problem, sorry. So 12 times 4 is what? 12 times 4, students. Let me do it. I know it's 48, but if you want to, check it on the side and do your multiplication, find the result of your multiplication, you can multiply it this way. So 4 times 2 is 8. We're cross multiplying, and 4 times 1 is 4. So you can do it the long way. Go back and do it the old-fashioned way. If you are a genius, then you should know this. If you have them memorized, you should automatically know this. All right. So, 4/12 is equivalent to 16/48. All right? So, I hope that this short lesson this evening for your students is helpful. And you can review this with them, or if you are in school or returning back to school after being out for so long, this is a good review, because you will see this, especially when you have to reduce fractions or figure out equivalent fractions. This would be very helpful. All right? Hi, Tina. Okay. I think this is it with our equivalent fractions that one of my students asked me to review. All right. And for tomorrow, my goal, if I am on between 3 and 4 tomorrow, I am going to talk about, my eraser is kind of getting, okay, I need some new dry erase markers. Okay, tomorrow, let me use green. All right, y equals mx plus b. I have some college students that are having to work out problem assignments, solving an unknown variable to graph their equation or to find the equation of a line. So this is the formula for an equation of a line. All right, so I'm just going to give you a little bit of the basic vocabulary, and tomorrow I will still review this and actually solve a problem. So this is the formula for an equation of a line, and I'm going to just go through some vocabulary. M represents the slope. Okay? For the slope, there is a formula that says it is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Okay? Your y's represent some number. Okay, I think I'm having an avalanche here. Give me a few minutes. All right. Hope you can still see. Okay. So y represents a number. Some number. So does your x value. So this represents some number. Okay? And you know that this is your numerator. Here we go with the fraction again. This is your numerator divided by your denominator. Here we go with that fraction again. Okay? So m represents the slope, and the slope comes from x. The slope comes from, let me put this here, your x and y values. Okay? These are your numbers. They are also called your values. Let me put here, this is also called your values or your numbers, unknown, where they have to give you some numbers or you can solve for it. So these are called your values sometimes, and this is also called, these are your values, it's also called your point. It could be 0.1 or it could be 0.2. Okay? It's also called ordered pairs. Okay? So this could be 0.1, and then you can have another one that's called 0.2 with x and y values. So this could be x sub 1 here. I'm going to put a 1 here. And this could be y sub 1 so you can understand where I'm going with this. 0.2 could be x sub 2 because this is 0.2, so this is x sub 2, y sub 2. All right? Sometimes they'll give you 1 point, or sometimes they will give you 2 points, maybe 3 points. So if you want to find the slope, you have to use this equation. So it is y sub 2. We say sub 2 because it's a subscript. So y sub 2 is here, minus y sub 2 minus y sub 1. X sub 2, which is here, minus x sub 1. So that's where we get our right now unknown values, because I didn't give you anything. I'm just giving you vocabulary right now. Okay? So let me just do this. Okay, so that's how we come up with the slope. Your y right now, we don't know what that is as of right now, unless we use from point 1 or from point 2, but I'm not going to get into that right now. I'm just giving you vocabulary so you'll know what each one of these letters mean. Okay, B represents, it's like 0 comma B. All right, it's the same thing as saying almost like your X and your Y. All right, but this is called your y-intercept. Y-intercept. Hope I can spell. All right, y-intercept. So that is what this is. And you can actually, later on I'm going to show you how to graph. We can actually graph an equation of a line. So when you think about an equation of a line, it tells you that you want to graph it, okay? So you want to graph it. So these points, which is called ordered pairs, or your, forgot about the name, other name, coordinates. Coordinates. Okay? So I'm just giving you vocabulary, as I keep saying, because this is a loaded, it can be a very intense problem, all right, to solve. But I just wanted to go over some of the vocabulary because the goal is to graph this equation of a line. And we have to be given some points in order to do that. And if they give you a certain type of equation, you can either solve for X, or you can solve for Y. Okay? So that is the goal that we're going to get to hopefully on tomorrow. How to solve for X and how to solve for Y if we're given a slope and an intercept, or we're giving the Y, the slope, and no y-intercept. Okay? All right. I think that is it. Let me just check. We talked about the points. Okay, we talked about that. Point 1, point 2, which is here and here. These are values called ordered pairs, or your coordinates. We talked about what M represents the slope. So I can put M right here equals that, so it looks like an equation. And they also, when we get ready to graph, this is also called rise over run. When we get ready to graph, you know, when we graphing on a coordinate grid or graph, and I'll do that for you later, not tonight, but we can either, when we are putting in like our values, or we graph or plot this, sometimes they say plot. Don't let it trip you up. Okay, plot means the same as graph. These are your points that are going to be on the graph, and it tells you which direction to go. So X it'll tell you if it's a positive X or a negative. It'll tell you either to run over positive or run back negative on the axis. We'll talk about axes and axis, y-axis, x-axis. That's on your grid, like your coordinate grid or your graph paper, okay? And then rise means you can either go up, positive, or you can fall and go down, negative, on the graph. All right? I know this is a lot of vocabulary for, right now, but it will make sense hopefully later when I go into solving a problem. All right, my Facebook students, I hope this is beneficial to you and other students. If it is, and if it's not for you, please like and share so someone can replay this on tomorrow or any other time and review this. Okay, so thank you for watching, and peace, be healthy and safe. Hi, Joy. I need to give you a call. I'm still up. Started out late. All right. Peace out, people. Be safe. Keep healthy. Like and share.